Today we want to look at, in this video, we want to look at how to solve the quadratic equation given here using the method of completing the square. So stay put, relax, as we enjoy the lesson together. Okay? We are here. Look at it. Very quickly, this term here, this one here, is called the first term. The first term. The whole of this one here is called the second. It's called the second term. Right? Now, this one here, 8 minus 8 is called either you call it the third or you call it the constant term. All right? So this is the third or constant term. All right. Now, the first thing to do when you want to solve this equation using the method of completing the square is to either you divide all through by the coefficient of s squared, or you isolate the constant term. Isolate it means you take it to the other side of the equation. All right, the other side of the equality sign. Okay, so let's go. So let's isolate the constant term. So if we do that, we're going to have a 12s squared plus 10x is equal to 8. All right, so you isolate the constant term. Step number 2, divide all through by the coefficient of s squared. The coefficient of s squared here means the number standing in front of s squared. All right, what you see here very clearly is 12. So we're going to divide all through by 12 so that we make the coefficient of s squared 1. Let's go. Divide all through by 12. So 12s squared divided by 12 plus 10x divided by 12 is equal to 8 divided by 12. Okay? Now, let's carry out a form of cancellation. 12 here, 1. 12 here, how many? 1, gone. So 12 cancel 12. Let's just say 12 cancel 12. 12 into themselves, you get 1 in this case. Now, if you come over here, if you reduce it, you have 2 here, you have 6. 2 here, you have 5 here. Let's leave this one here for some reason, even though we can reduce it, but let's leave it like that. Okay? Now, what's the next thing? You write out what you have left. So you're going to have, s squared plus 5 over 6x is equal to 8 over 12. This is what we have now. Now, so step number 1, we isolated the constant term. Step number 2, we divided all through by the coefficient of s squared. And we are now here. Step number 3 now, identify the coefficient of x. Take half of it, square it, and add it to both sides. That's the next step. So identify the coefficient of x. Let's go. Coefficient of x here is 5 over 6. This is the coefficient of x squared. What do? You identify the coefficient of x, which we have done, a 5 by 6. So what do you do with it? You square it. You take half of it, rather, you square it and add it to both sides. Square it and add it to both sides. All right? So let's have that. Let's have that together now. All right? So if you take half of 5 over 6, it means 5 over 6 multiplied by a 1 by 2. If you want to take half of 8, for example, it's either you do 8 divided by 2, you get a 4, or you say 8 multiplied by a 1 over 2. It's the same thing. All right? So half of 5 over 6 is going to give you what? 5 over 6 is going to give you a 5 over 12. So this is half of 5 over 6. Now what do you do now? Square it and add it to both sides. So let's do that together. So the square of this one means 5 over 12 all squared. This is what you're adding to both sides of the equation. Now let's go. Let's do that together. Let's do that. So you're going to have x squared plus 5, x squared plus 5 over 6x plus, then you now add that. If you add that, you're going to have a 5 over 12 all squared is equal to 8 over 12. And then, okay, let me take it to this other side so that we have more space to accommodate this. All right. So let's have it here, over here. So we're going to have x squared plus 5 over 6, x squared plus 5 over 6x plus 5 over 12, 5 over 12, yes, or squared is equal to 8, is equal to 8 over 12, and then plus the same 5 by 12, all squared. Now, by taking the coefficient of x, by taking half of the coefficient of x, squaring it and adding it to both sides, we'll be able to tactically we have made the left-hand side a complete square. The whole of this left-hand side now has become a complete square. What does it mean for an expression to be a complete square? It means it can be written to an even power. For example, if I have x squared plus 6x plus 9, for example, the whole of this one can be written as x plus 3 all squared, like this. If you expand this expression here, you are going to get this one. So writing an expression to power 2 like this, or power 4, or to any other even power, is what it means to have a complete square. Is that okay? All right. Now let's go back here. So when you want to write this left-hand side as a complete square now, see what will happen. Left-hand side as a complete square, you are going to have so if you take the left-hand side as a complete square, see what will happen. Take x here without the square, you have x. Go inside the bracket here where you have square. Take what? A plus 5 over 12. Yes, there is no sign here. It means that there is a hidden plus in front of that 5 over 12. Now, put a square above the two of them. Put a square above the two of them this way. What it means is that if you expand this expression, it will give you the three of them. Please, if you have a challenge on how to expand the shortcuts we apply to expand binomial expression to power 2, the shortcut, please check out one of my videos and then before you come and continue. Thank you very much. Okay, so we took x without the square and we came inside the bracket here. There is a hidden plus here. Without the sign, it shows that there is a plus here. There is a hidden addition sign here. So that was why we took the plus 5 over 12 and we put the square above the two of them. Okay, now let's go back. Let's go. So at the right hand side, you are going to have at the right hand side here, you are going to have 8 over 12 plus. If you square 5, you get a 25. If you square 12, you are going to get a 144. Okay, now let's simplify the right hand side. Let's go. So we have x plus 5 by 12 all squared is equal to the LCM of the denominators here is 144. You have it there. All right, so we go 144 divided by this denominator, this 12. You get a 12. 12 times 8, you get a 96. So you have 96 there plus this is 6 carry 1 and then 8 plus 1, 9. Yes, 96. Yes, we're fine. Okay. Now, what do we do next? 144 divided by this 144, you get 1. 1 times 25, you get a 25. Okay, let's move on and see how it goes. So on the left hand side, we have x plus 5 by 12 all squared is equal to, if you add up these two things, you are going to get a 121. 121. So we have 121 all over 144 this way, right? Okay. Now, in order to cancel this square that is here, this square here, we take square root of both sides to enable us to do that. Okay. So to remove this square from here, we take square root of both sides. So if you do that, you're going to have x. You're going to have x plus 5 by 12 plus 5 over 12 all squared. We put a square root sign above it is equal to, we put a square root over here, 121 also. We have 121 all over 144. So we keep on going. Now what will happen here? We're going to have square, this square here will cancel out the square root sign, or the square root sign will cancel the square. What do you have next? You now have just x plus 5 over 12 is equal to. Now, if you want to find square root of 9, for example, square root of 9, the answer to the equation is plus or minus 3, not just 3. That's because if you square, what I'm saying is this. Let's just suspend this one for now. If I say square root of 9, the answer is plus or minus 3. Do you know why it is plus or minus 3? Because if you square the 3 back, if you square the 3, you get 9. Even if you square minus 3, it will still take you back to what? To 9. That's why we say square root of any number is plus or minus an answer. Okay? That means that over here, square root of 121 is 11 over, let me put the plus or minus first because we are taking square root, so we have plus or minus waiting. Square root of 121 is 11. Square root of 144 is 12. Okay? So let's carry on. Alright, so we go. We have, alright, so let's carry on. Okay? Now, let's move this to the other side. Let's move this plus 5 over 12 to the other side. So we have x is equal to, if you move it, we are going to have a negative 5 over 12 plus or minus 11 over 12. Alright? Now, because of plus or minus, we are going to have two answers. We're going to say either x is equal to negative 5 over 12 plus, we take the plus 1, like the addition sign, plus 11 over 12 this way, waiting for an answer. Or the next one we're going to do is to say what? The next one we're going to do is to say, alright, next one we're going to do is to say what? Alright? Or next is s is equal to what? Let's move it a little. S is equal to negative 5 over 12. We take the minus sign this time around, this other minus 11 over 12. Now let's start and finish up this and see how it goes. Let's start and finish up. Return here. The two of these fractions are like fractions, so they will share the same denominator. So we just have it as well. Negative 5 over 11. Over there, waiting for an answer. You come over here, they also have the same denominator, 12 and 12. What do? We have a negative 5, negative 11 divided by 12, waiting for an answer. Now, we go. Now, negative 5 plus 11. Negative 5 plus 11, you were owing a 5, now you have 11. If you pay back the 5, you'll be having 6 divided by 12. This way? Yes. So you have 6 over 12. Now, 6 over 12, you can break it down into something. 6 over 12, you can say 6 here, 1. 6 in 12, how many? 2. That means that x value is 1 over 2. Or, when you come over here, minus 6, minus 5, minus 11. Borrow 5, borrow 11. Altogether, you are owing a negative 16 over what? 12. Okay, so you can break it down a little and see how it goes. If you do that, 4 is common to the two of them. So 4 in 16, you get a 4. 4 in 12, you get a 3. Meaning that the second answer is a negative 3 over this. So we can boldly say now that what? We can say therefore, x is equal to what? A 1 over 2, or x is equal to what? A negative 4 by what? A negative 4 by 3. This is how we finish up this. Alright? So this is, so we have successfully solved the quadratic equation given to us by the method of completing the square. Now let me give you something to try using the same, let me give you something to try, a similar question to solve by the method of completing the square. Okay? So when you are done, please do well to give me feedback by putting your answer in the comment section. You have to solve this equation here by the method of completing the square. Please, when you are done, do well to like, to share, to subscribe if you are here to do so, to follow if you are here to do so. Please do well to tell somebody about Math Albertois. Till we see again in another video. Bye for now.